This episode is going to be on a project that's on page 144 of your Ignition manual. And this project can be completed with all three of the Rockwell automation platforms using our controller manuals. But you don't have to do that. Once you start learning Ignition, you realize it's just a matter of being able to access the tags in your controller and not about the particular brand. You just need to identify the paths through the network to the controllers into the tag databases and associate the tags with the objects on the screen. And remember that this is not an engineering project. This is a learning project. This project is designed for you to learn how to work with PLCs, PACs, controllers, and with HMIs. And we have worked to integrate the HMI part of it into the PLC learning part of it and make it all one. And demonstrate how when you're online with your program and your programming software, and you can alter the value of tags in the controller, live, online, that's no different than an HMI. An HMI is much more sophisticated. So keep in mind when we do these projects that the PLC controller programming, it's not perfect. I created it just enough to do enough for you to get started and learn something. And it's the same thing with this HMI, Ignition Vision. I'm just giving you I'm kind of greasing your skids into it. And once you get in there and you start getting a handle on it, you can go anywhere you want with it. Don't feel that you have to match what I've done and shown in the manuals verbatim, point by point. Get in there, get something to work, and once you've got it under control, then use your imagination. A lot of what we do in this project is visibility, things appearing, disappearing, if you like, the visibility. Like the rod strokes on the cylinders. We've got two positions for the end actuators, and we use visibility to control which one is there. If I put this, I see it's already in the run mode. If I click on 1PE down here, remember this is photo I1 up here, it sees a part come from upstream and hit the barcode scanner. And we basically, when you click on 1PE right here, you're not turning on the photo eye. You're saying, I'm putting an object in front of 1PE. When I do that, see, now an object appears in front of the barcode scanner, and then the PE1 multi-state indicator here changes color to green with white text to show that it sensed an object. But what you're doing with this button down here is you're not turning on the photo eye. You're saying, put a part in front of that photo eye. And the same thing all the way through here. Now, depending on which hardware platform you're using in the manuals or not, we had virtual or simulated photo eyes PE3 and 4. Because of the limitation of switches and lights on our digital field device simulators, we couldn't have as many photo eyes attached to toggle switches as we needed. In the original project, you had this first photo eye, PE1, the second one, PE2. That way we could extend cylinder 2 and 1 to block any more parts. And then once it got into this space, we actually used the fact that PROX2 on cylinder 2 said it was extended to say that the part's sitting right there in front of PE3. We had a virtual photo eye that we created with logic. Now we're not doing that in this case. Same thing with PE4 down here. We could only spare 3 real inputs on the hardware trainer to assign to photo eyes. And the same thing with outputs. We couldn't afford to have outputs for everything because we've got 5 cylinders. Well, that would be 5 outputs all by itself and would eliminate any other outputs that we could simulate with a digital field device simulator. This is just to get you started. And you see that we have a part here in front of photo eye 5, and that just happens to be way the way this was left yesterday when I was playing with it. If we want to get rid of that part, we have to get the takeaway conveyor here to turn on, and we have to get cylinder 5 to retract. I'm not going to do that right now. I'm going to stop at this point and go back to the beginning. But please keep in mind that this is just a starting point for you. I just gave you something that works, not perfect. If you want to improve the animation, I have parts appear and disappear. They disappear like this first one up here. If I turn off PE1, it's going to show up down below here. You're not going to see it move and travel. It's just going to disappear from one position and show up in another. Another thing that you can animate, you see these yellow dashed lines from the photo eyes? I could decide that I want them to change in appearance when there's a part blocking it. I could take that, I'll take this out of preview mode, and I'll go select that line. I could duplicate that, make one a different color, put one on top of the other, and then control the visibility, change the length, the shape, the color, and everything based on logic. That's where you're supposed to be going with this. Don't stop with what I've got right here. You got to take this and keep on rolling, and that goes for all the projects that we do in all of our PLC controller manuals, and especially in the HMI. You got to use your imagination. Just to cover all the bases, remember that there are 3 controller sets of manuals. The original ones that I wrote were for, we'll call it Slick 500 Micrologics, and then sometime later RSLogic Studio 5000, and then sometime later Connected Components Workbench Micro 800. The original set of manuals, the orange and black ones for, we'll call it RSLogic 500, the Micrologic 1400, Slick 500. There were 3 types of programming. In this particular process that you're looking at, I use latch and unlatch. As each step occurred of a part coming in, I would latch a bit saying that that step was complete. That would enable the next step, and so forth all the way through. But you couldn't start a second part into the system until the first part got all the way through. I went to seal-in logic. In other words, I switched from latch and unlatch. We have a saying in the industry, if you use latches, then you have to unlatch the whole world, because one of the downsides of using latches, you can latch a bit in memory as many times as you want. Now, if it's already latched on, you can't latch it on again. It's already latched. And you can unlatch it anywhere, which means that the logic that latches the bit and the logic that unlatches the bit, or you could say set and reset, it can be anywhere in your program. However, with seal-in logic, typically the conditions that turn on the bit and hold it on are right there in the same rung, and when those go away, the OTE, which has a true to false execution, if the rung's true, it turns it off. If it's false, it turns it off, whereas latch and unlatch do not. When you use latches, the unlatches can be anywhere in the program, and if you go through and create a bunch of latches, then you got to go back and unlatch them all. We went from latch, unlatch, or set reset logic to seal-in logic, but still one part had to go all the way through the system, which means that the logic was interdependent, and that's not the kind of logic you want to write. The third method, and we do this in the manuals, was to use seal-in logic, but to write it in such a way that each rung of logic was independent of other rungs, to the extent of you could start more than one part. You could have one part halfway through and then start another one and end up with 3 parts. You could have a part at the scanner, a part at cylinder 2, a part at cylinder 4, a part where PE4 is, another part where PE5 is, and then yet another one going off the conveyor. Keep that in mind when you're doing this project. It depends on your logic, but your HMI should behave the same no matter how you wrote your logic and no matter what platform you're using. In an effort to keep these videos under 15 minutes each. I'm going to stop right here and just call this an introduction into that project, and then I'm going to start another recording actually operating and discussing this project in more detail. Thank you for watching.